Alright, let's get started with 4.3, which is right angle trigonometry. So we're going to take what we've started with on the unit circle and now be able to apply it to any right triangle, any triangle with a 90-degree angle in it. Alright, so some definitions to get started with. If we have an angle in one corner of a triangle, alright, we're going to have some definitions of our sides. The side that is across from the 90-degree angle is our hypotenuse. I think we know that. We're going to call the side away that is not touching our angle the opposite side. And the side, this is cut off here, but this is the adjacent side here. Okay, adjacent side of the triangle. Alright, so for sine is going to be defined as the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Okay, these are things we already know from the unit circle. We just haven't put them in these terms because on the unit circle, sideways is an x value, up and down is a y value, and the hypotenuse is the radius of our circle, r, which on the unit circle, that was just 1, right? So sine, opposite is the y side, the hypotenuse was 1. That's why sine is just equal to y on the unit circle, right? Y divided by 1 is just y. All right, so on this one, we're going to call this the hypotenuse, adjacent, and opposite over here. And there is a nice way to remember sine, cosine, and tangent, and that is the pneumatic SOHCAHTOA. Sine is the opposite over hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite over adjacent. And then cosecant is the reciprocal. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So let's go ahead and use this. So we have a triangle, we have an angle theta, and we have the adjacent, and we have the opposite sides. The hypotenuse here we don't know, but we should be able to come up with it using our old friend the Pythagorean theorem. That's going to be 5, right? 3 squared plus 4 squared is 5 squared. So let's knock out our 6 trig functions: sine of theta, cosine theta. Just going to write them all up and then we'll fill them in. Tan theta. And then the flip of sine is cosecant. The flip of cosine is secant. And the flip of tangent is cotangent. Sine is opposite 4 over hypotenuse 5. Cosine is adjacent 3 over hypotenuse 5. Tangent is opposite 4 over adjacent 3. And then let's flip them all over. 4/5 turns into 5/4, 3/5 turns into 5/3, and 4/3 turns into 3/4. And there we go, we've got all 6 trig functions of theta. Your turn. Figure them out for number 7. Okay, let's find the values of sine 45, cosine of 45, and tangent of 45 if we're given all the sides. So sine of 45 is opposite 1 over hypotenuse, root 2. Got to clean it up. Okay, so we end up with root 2 over 2. And that should look very, very familiar from the unit circle. Cosine of 45 is the exact same thing because it's also 1 over root 2, which, as we did above, turns into root 2 over 2, which is also the x value at 45 on the unit circle. And then tangent of 45 degrees. Opposite is 1. Adjacent is 1. We just get 1, which is what we would have gotten if we divided sine divided by cosine, what we were doing on the unit circle. All right, so using that knowledge, see if you can fill this table out for 23. All right, example 3. Use the equilateral triangle. Remember, equilateral means that to the outside angles are going to be the same, and then the bottom is also 2. So all the sides are the same. Equilateral, all three sides the same. Find the values of sine of 60, cosine of 60, and sine 30 and cosine 30. All right, so if we have 1, 2, and root 3, we're really just dealing with this triangle here. (30) and 60. All right, let's start with 60. Sine of 60. So we're here. We're going to go opposite. So root 3. Opposite from the 60 is root 3 over the hypotenuse, which is 2. We need to do the cosine of 60. From 60, the adjacent is 1. The hypotenuse is 2. All right, now let's do the sine of 30. So now we're going to switch angles. Now we're talking about this angle up here. From there, the opposite is 1/2. Sorry, opposite is 1. Hypotenuse is 2, so sine is 1/2. And then the cosine of 30. From the 30, the adjacent side is root 3. The hypotenuse is 2. And so you should start seeing some similarities. The cosine of 60 is the same as the sine of 30. What this means is that if you're in a triangle and we switch angles, we go from the 60 and instead decide to go over to the 30, sine changes to cosine. Okay, so that is going to come up a lot. All right, use that knowledge, see if you can finish problem 27. Okay, so now we're going to take that idea one step further. So we know that sine of 30 and cosine of 60 are the same things, right? They are both 1/2. That's true anytime the angles add up to 90, because any two angles inside of a triangle. So anytime we go 90 minus an angle, that's really the same thing as saying the complement, right? 30 and 60 are complements. So if we do the complementary angle from sine, we end up with cosine, okay? And then the rules apply also for tangent and cotangent, secant and cosecant. And it works the other way as well, which is what all of these are saying. All right, so cosine of 60 is sine of 30. Cosine of 1 degree is the sine of 89 degrees. Right? If the two angles add up to 90, one's going to be cosine and one's going to be sine, and they'll be equal. All right, so now we have some more trig identities. We've already done the ones on top in the unit circle. Sine is the reciprocal of cosecant. Cotangent's the reciprocal of tangent, okay, for all 6. We can also say, because tangent is y over x, that's the same as saying sine over cosine. And the same goes for cotangent. Okay? So now we can do some Pythagorean identities, and this one here comes from the Pythagorean formula, right? A squared plus b squared equals c squared. So if you're on the unit circle, y squared plus x squared is r squared, and r is just 1. 1 squared is 1. So sine squared plus cosine squared equals 1. From those, we're not going to go into them too much right now, but 1 plus tan squared is secant squared, and 1 plus cotangent squared is cosecant squared. Just have those in your bag of formulas for this chapter. We'll talk about why a little bit more in class when we do some of the problems. Okay? All right. One thing to talk about, the way we write sine squared, we could write it like that, but most typically it shows up like that with the 2 in between the sine and the theta. It's just a convention for how we write it. Okay, sine squared theta means sine theta times sine theta. All right, so let's see if we can do this example here. Let theta be an acute angle such that sine theta equals 0.6. What I'm going to do is I'm going to draw a right triangle. I'm going to decide one of the angles to be theta. And now from there, I know that sine theta is opposite over hypotenuse. So I must have 0.6 over 1. Or if I wanted to, I could say 6 over 10. I'm going to do that just so we don't have decimals here. So 6 and 10. And I want all 3 sides of the triangle, so I'm going to go Pythagorean. X squared plus 6 squared is 10 squared. This is a Pythagorean triple. It's going to end up being 8. I'll do the math all the way out. X squared equals 64. So it's going to be 8 for our adjacent here. Okay? So let's find cosine and tangent. Cosine is adjacent over hypotenuse, so 8 over 10, which is 0.8. Tangent is opposite over adjacent, which is 3/4, which is 0.75. All right, so in these problems, if they give you a trig identity, draw a triangle, see if you can fill in all three sides. That's your job here for 33. Okay? All right, let theta be an acute angle such that tan theta is 3. Find cotangent and secant. All right, I'm going to do this an opposite way. So the first way we have is to use a triangle, draw a triangle. The second one is to use the identities. All right, so if I know that tan theta is 3, I know that cotan, using my identities, is the reciprocal, is 1/3. I can go straight to it. I know that secant, now I'm going to flip back here to our formulas. Secant squared is 1 plus tan squared. Secant squared is 1 plus tan squared. I know that tan is 3, so tan squared is 3 squared. All right, so 1 plus 3 squared is 10. Secant squared theta is 10. So secant must be the square root of 10. All right, so there's two different ways. We can either make the triangles and figure them all out, or we can use the formulas that were given in the identity section. All right, so see if you can do it without drawing a triangle. See if you can do 35 with just using the formulas. All right, so number 6, we're going to jump into the calculators. We want to do secant. Same thing, we've seen this type of problem already in 4.2. We need to turn 40 into a decimal, so 40 over 60. And we need to turn 12 into a decimal since it's seconds. It's 12 over 3600. There's 60 times 60 seconds in a degree. We get 5.67. All right. We want to find the secant of that. We don't have a secant button on our calculator, but we sure have a cosine button. And secant is the flip of cosine. So this would be the steps to plug it in. Cosine of 5.67. Then we want to do the reciprocal, which is the x to the negative 1 button. Hit enter, and you're going to get 1.004916. Your turn on 51. See if you can get A and B to come out with the correct answers. Okay, so now we're going to get into some real-world examples here. One thing that we need is angles of elevation and depression. An angle of elevation means start from the ground and swing up. An angle of depression means start from the sky and swing down. We'll use this for problems where we're standing at the top of a building or we're in a plane or things like that. All right, so here's our first one. Surveyor standing 115 feet from the base. Our angle of elevation is 78.3. And we want to find out how tall this thing is. All right, so from 78.3, I need to figure out what I have. 115 is an adjacent angle. Y is an opposite, not angle, opposite side. 115 is an adjacent side. Which formula, which trig function uses adjacent and opposite? If you said tangent, you're right on the money. So the tangent of 78.3 equals opposite y over adjacent 115. And so we're going to go tangent of 78.3 equals y over 115. Let's grab the calculator real quick and do this. Now, one thing that you want to make sure you're doing is that you're in degrees for this problem, because 78.3 is a degree. Okay, so we are going to have to switch back and forth in this section. So tangent of 78.3 times it by 115, and 555.31 is your answer. Same thinking for 67. See if you can do it. Okay, so 8. We have 200 feet for this side of the triangle, 400 for this side. We want to find theta. All right, so this is going to be an opposite side. 400 is a hypotenuse. The formula that uses opposite and a hypotenuse is sine. So sine theta is 200 over 400. 200 and 400 reduces. Sine theta is 1/2. Go look on your unit circle. Find the angle when y is 1/2, and you should come up with 30 degrees. Okay? You're going to do the same thing here on problem 69. All right, last one. Let's find the length of the skateboard ramp C. We know the angle is 18.4. We know the opposite is 4. C is a hypotenuse, same type of problem we've been doing. Sine is what we want because it's opposite over hypotenuse. Sine of 18.4 equals 4 over C. Okay? So let's rearrange this. We could times C on both sides and divide by sine. So C is going to be 4 divided by sine of 18.4. To the calculator we go. 4 divided by, make sure you put it in parentheses, sine of 18.4. 12.67 is the length of that skateboard ramp. Finish it up with 71, and that's all there is for 4.3. Questions on this, we'll go over them in class.